Hey, welcome back. In this video, we are going to study about hybridization, bond angles, molecular shapes, and their geometry, which is usually categorized under Vesper theory. So in order to understand these concepts, you should understand what is our central atom, or we can categorize it into domain. So the domain, we have a domain number or total domains. When they talk about domains, that is how many bonds and lone pairs are bonded to the central atom. So the central atom could be like, let's imagine you have a nitrogen with three hydrogens like this and with a lone pair. So now this is our central atom and this has a domain number of lone pair plus 3 bonds. So this gives us a domain number of 4. So let's see how does this domain number helps us to recognize these things. So the domain number can be 1, 2, 3 or maximum up to 4. So 4 is where our octet is filled. So whenever you have a domain number 1, that means it has one bonded atom, 0 lone pairs, and the hybridization is S. So, and the bond angle here, because it's only one bonded atom, it will be just 180, and their electron geometry will be linear and molecular shape also will be linear. So this one, the only example that really applies to here with hybridization S is just our hydrogen, H2. So we don't usually come across that one. So then you have a domain 2. Domain 2 means, it could have two bonded atoms or one bonded atom and one lone pair. And that falls under hybridization of sp. And they have a bond angle of 180 and the electron geometry is linear and the molecular shape is also linear. So what is the difference between electron geometry and molecular shape? So let's take the same example what we took earlier of ammonia. So for electron geometry, you consider this lone pair as well as the 3 bonded atoms. But for molecular shape, we are not considering the lone pair, which we can't see. So we just consider these 3 bonded lines. So this will help us to determine what will be the molecular shape or molecular geometry. Sometimes the question is asked as what is the geometry around the molecule. So then you will give the molecular shape. When they ask you the geometry of electrons, you go for the electron geometry. I hope that helps. And so when you have domain 3, so same thing. It is 3 bonded atoms or 2 bonded atoms and 1 lone pair or 1 bonded atom and 2 lone pairs. And that hybridization falls under sp2 with a bond angle of 120 and the electron geometry of trigonal planar. So the electron geometry is common because irrespective of whatever, electron geometry depends on domain. While the molecular shape depends on how many bonded atoms it is. So since it is 3 bonded atoms, the molecular shape is trigonal planar. If you have 2 bonded atoms, it's bent shape. And if you have only 1 bonded atom, it is linear. And the best examples I can give you here for 3 is, let's consider AlCl3. Aluminium with 3 chlorines. Aluminium will not have any lone pair. If you want 2 bonded atoms with 1 lone pair, you can take probably tin, SnCl2. Tin has 1 lone pair and 2 bonded atoms. And if you want 1 bonded atom with 2, let's go with O2, oxygen double bonded oxygen. So that gives you 1 bonded atom with 2 lone pairs. Okay, I'll go into detail about this double bond, why it is 2, because when we say lone pairs are 2 and bonded atom 1, we're talking about sigma bonds here. So the bonded atoms, sigma bonds. That's why the sp2, whenever you have a carbon double bonded carbon, it's sp2. Whenever you have a carbon triple bonded carbon, because you have only one bonded atom here, this one is considered as sp, because we're just focusing on the sigma bond between the carbon and the carbon. Oh, by the way, here, we will look into that even further. So now the most important one is 4. So domain 4 is the most common one we come across, which falls under the sp3 category. So when you have domain 4, it could have 3 lone pairs, 1 bond, or 1 lone pair, 3 bonds, 2 bonded atoms, 2 lone pairs, or 4 bonded atoms. So usually the 4 bonded atoms is the best example is our CH4, carbon with 4 bonds, all 4 sigma bonds. Let's focus on that. And 3 bonds with 1 lone pair, come on, we have our ammonia here, NH3, where nitrogen is bonded to 3 and has 1 lone pair. And 2 bonds, 2 lone pair, you know what, you can take an OH or water. It has 2 bonds and 2 lone pairs on this oxygen because oxygen is our central atom. And 3 lone pairs, 1 bond, you can be our chlorine, bromine, iodine. So all of this have a bond angle of 109.5 and they all have an electron geometry of tetrahedral shape. So the molecular shape for 4 bonds is still going to be tetrahedral. So 3 bonds, 1 lone pair will be a trigonal pyramid. 2 bonds, 2 lone pairs will be a bend shape, and 1 bond, 3 lone pairs is going to be a linear shape. So the best way is to look at more examples. We can just try some examples as well. The best one here, I can give you another example. You have been given a structure like this, double bonded oxygen. And they may ask you, hey, what is the electron geometry at number 1? And what is an electron geometry at number 2? So at number 1, you see this carbon here. This carbon is having a double bond. So we count only the sigma bonds. So 1 sigma bond, 2 sigma bond, 3 sigma bonds. And carbon there has no lone pairs. So that is going to be an sp2 hybridization with a geometry of trigonal planar. While at number 2, this carbon here is having all 4 sigma bonds, which will fall under 4. So this hybridization is going to be sp3 with the molecular structure of tetrahedral. So this is how they can ask you the questions in this particular topic. So I hope this helps, and thank you.